Thank you for your interest in IBM Informix Database Technology. In this presentation, I'll introduce what Informix TimeSeries technology is and how it is unique in the market today. I'll highlight a few of the industries and use cases for the technology. I'll cover at a very high level how Informix TimeSeries is configured and activated. And finally, I'll provide links to where you can get more information about Informix and its technologies. Informix has the unique ability to ingest, store, and use time-oriented data much more efficiently than a traditional database. This data can come from regularly occurring or random ad hoc events. Informix TimeSeries is built-in functionality in all Informix editions and can be used without an additional license fee. The key to Informix's time-oriented efficiency is a custom object-oriented data type called TimeSeries, which is highly optimized for storing and accessing time-based data. With this data type, time-oriented data can shrink in size from hundreds of gigabytes or multiple terabytes to a tiny fraction of the original size. Query times against Informix TimeSeries return in a fraction of the time it would take to execute in a traditional database topology. In fact, it is not uncommon for query times to decrease from over an hour to just a few seconds with Informix TimeSeries. In a traditional database, storing time-oriented data requires a separate row in a table for each data value. This often results in tables with billions of rows, which is unmanageable from a storage and administrative perspective. Most of the data in these rows is redundant. The device name or type doesn't change from one event to another, but must be included in the row and is usually indexed. Index maintenance on this type of table is almost impossible as the row count grows. Trying to query data from the table is just as painful. In Informix TimeSeries, all readings from a particular sensor or device are stored in a single row. The redundant data is factored out and stored in a set of index columns within the row. The data values themselves are stored in a time-based array in another column within the table. As a result, the table row count shrinks to just the number of data-generating devices, and there is no redundant data. The data elements themselves are quickly and easily accessed, either based on an offset from the beginning timestamp of the array to the requested moment or range of time, or using a specific timestamp or range of time. Each time series can be optimized for the frequency of data it will store. There are two general classifications: regular or irregular. As the word implies, a regular time series expects to receive data on known and fixed intervals of time. Whether that interval is measured in subseconds to years doesn't matter. The series will begin expecting data from a known moment in time going forward. Intervals can be missed, and a null placeholder will be put into the series. Missing data for the interval can always be backfilled. Data can be modified as needed too. There are no restrictions on the data which can be stored in a regular time series. It can be one or more traditional data types like character or numeric data types. With Informix native NoSQL integration and support, a time series can also store one or more JSON documents, or the data can contain both traditional and unstructured data. The data itself is accessed via time-based offsets within the array from its known starting point. An irregular time series will store data received randomly over time. Whether that interval between data values is measured in subsecond to years doesn't matter. There are no missed intervals or null placeholders in an irregular time series. There is simply no data to record. Data for earlier intervals can always be backfilled, and data can be modified as needed too. Like a regular time series, there is no restrictions on the data which can be stored in an irregular time series. It can be one or more traditional data types, it can be one or more JSON documents, or the data can contain both traditional and unstructured data. Because there isn't a fixed interval in which data is received, an irregular time series stores the time value itself in the data element, and data is returned by querying on those timestamps. Lest you think this is inefficient and ineffective, an irregular time series generally has significantly fewer elements in it, and the timestamp itself is part of the array's built-in index structure. An interesting characteristic of any time series is that it can be defined to ignore values during certain periods of time. Called on or off periods, you can precisely define when you want a regular time series to store data and when you don't. This is particularly useful for regular time series when data won't be received for a span of time. For example, if the time series is monitoring equipment only used during the normal work week period, you can define an off period that starts at 5 p.m. and ends on the following 8 a.m., as well as all day on Saturday and Sunday. This would eliminate a large number of null placeholders in the series which would never be filled, increasing its overall efficiency. On and off periods aren't as important to irregular time series since they don't expect data at fixed intervals, but could be used to prevent spurious data from being stored. For example, data generated as a result of regular maintenance work on earthquake sensors, which, hopefully, do not trigger very frequently. Informix TimeSeries is not new or untested technology. It was developed and released in the mid-1990s for several financial firms to track stock market transactions in real time. Since then, its use has expanded to virtually every industry in the world. It's used to monitor traffic patterns and bridge utilization and stress measurements by government planners. There are agricultural customers using it to monitor food and field conditions to prevent or eliminate spoilage and other waste. Throughout the world, cities are rolling out smart meters, and time series is being used by many to efficiently store usage and quality of service information, as well as prepare billing statements and other reports. Time series is the foundation for capturing scientific readings in some of the most advanced atmospheric monitoring projects, and much, much more. Perhaps the most exciting use of Informix time series technology is in the Internet of Things space. Sensors and other data-generating devices are literally exploding in number, providing the ability to monitor and capture more information about the equipment, services, and even people we interact with. At its core, Internet of Things data is multidimensional. There is the data itself, or what happened, but time is also another critical dimension. When did it happen? The third most common dimension is location, or where did it happen? With this explosion of data, it is critical that it is captured, stored, triaged, and parsed, then used efficiently. The IBM model for handling Internet of Things data is a little different than other companies who propose capturing everything to a central repository in the cloud or on-premise. That's an expensive and laborious model fraught with risk for effectively and efficiently handling and securing the data. Instead, IBM's model starts with the actual devices themselves generating the data. These devices are typically, quote, at the edge of the network, end quote, and are often low-powered or lack consistent connections to other upline devices or services. IBM recommends devices connect to and use a smart gateway deployed very close to these devices. This gateway could be something as simple as a Raspberry Pi. The gateway contains the Informix database, which captures and stores the device data in whatever its format within a time series. Because the Informix running on the gateway device has the same functionality as Informix running on a large corporate server, programs can be written to parse, triage, or otherwise analyze the data at the gateway level. The data can be aggregated, summarized, transformed, or otherwise operated on, so only the values that are really important remain. Other programs can also monitor the raw data feeds and automatically execute actions if data conditions indicate there's an out-of-bounds condition. Using built-in replication technology, the Informix engine on the gateway seamlessly transfers the triaged data to a larger corporate server deployed either on-premise or in the cloud for more in-depth analysis or other work. This significantly reduces the amount of data transferred and the network infrastructure required to support the entire solution. In addition, this corporate server doesn't have to store and process all of the detailed level data from each device. As a result, you don't have to spend as much for processing and storage in the corporate server environment. Again, since the Informix in the corporate server is the same as on the gateway, only one class of applications are required. What runs on the corporate server can also run on the gateway and vice versa. This dramatically reduces application development and maintenance costs. Here is a real-life example of this architecture in action. An environmental sensor is capturing and publishing temperature information. It is captured by Informix running on the Raspberry Pi and stored in a time series. As you can see from the screen capture, it is an irregular time series. The Informix on the Raspberry Pi supports application processing on its data. In this case, the business realizes it doesn't need each and every captured temperature value. Instead, average readings over time is sufficient. A program to create a simple rolling average on a 20-second boundary in real time as the data is received is created. The results of the program are stored in a separate time series. In this screen capture, SQL view functionality is being used to present the data as though it's in a relational tabular format. The individual detail level readings are purged later as part of the automatic maintenance process. Using Informix Enterprise Replication technology, which is not shown here, the summarized data, still in NoSQL and time series, is transferred in real time to a corporate server without any additional application processing. The corporate server contains customer data stored in traditional SQL tables. Since the NoSQL data types are first-class data types in Informix, they can be used in any data operation. In this case, an SQL statement is used. The first line gets the structured data from the customer table. The second line extracts the time component for an averaged element in the time series and reformats it. The third line extracts the averaged NoSQL data itself from the time series element. In the rest of the statement, the correct customer information is joined to the time series element and the results are displayed. As you can see, SQL and NoSQL data is stored in the same database and is used together in a single statement. No other database in the world can perform this type of operation. There are a number of steps to configure and use time series within an Informix database. This section will provide a very high-level overview of the process. For more details, refer to the Informix documentation. It's important to understand that a time series is just a column in a table. While the column uses a complex extended type, it's just a column. The first step is to define time for the time series. A time series needs to know when it starts and, if it's a regular time series, the capture interval or how often to expect data. The begin date can be any time from January 1st, 00 AD into the future, depending on business requirements. When defining time, you can also indicate if there are any on or off periods when data will not be captured. Time is defined by inserting data into a special time series table called the calendar table table. It's also possible to define calendar patterns, which can be used across multiple time series calendar entries, but that's not covered here. Since Informix supports NoSQL programming languages, it's possible to define almost all time series elements using either SQL or NoSQL extensions as illustrated here. In both of these examples, a 1-second interval time definition is being made. The next step is to define what data will be captured in the time series. As mentioned earlier, it can be traditional data types, unstructured data, or a combination of both. The definition itself is encapsulated in a named row type, one of the extended object-oriented data types Informix supports. In the first example, a series of traditional SQL data types with depth and temperature information will be stored. In the second example, an unstructured or NoSQL document will be stored. Next, the time series table is created. It will have at least 2 columns, a key identifier column and the time series column. Any other column should contain the unchanging or redundant data, since it only needs to be stored once for the device generating the data. When creating the table, the named row type defined in the previous step is encapsulated into the time series data type for the column. In the first example, a simple 2-column time series table is created with what appears to be scuba diving data. The first column is the dive identifier or dive number, and the time series column will capture the 4 values from the named row type created earlier. The second example also contains scuba diving information, but in this case, additional reference data is stored in the table's columns along with the time series data in a NoSQL document format as defined earlier. Because time series is an object-oriented data type, standard SQL operations can't execute against it. For third-party tools such as IBM Cognos or regular SQL operations to use the data, a special view called a virtual table can be created to mask the data so it appears like regular tabular columns and the operations can execute. There are a large number of options available when creating a time series virtual table, but this example is the most basic. The results of an SQL query through the virtual table to time series data is illustrated as well. It looks like regular tabular data. While time series is just a column in a table, its data cannot be stored with the rest of the table's information. A specialized location must be created with the appropriate time series metadata structures. This specialized storage allocation is called a container. A time series can be fragmented across multiple containers if needed for storage capacity or other administrative reasons, for example, to simplify purging of older data. There are a number of options when defining a container. In this example, the most basic are shown. Like an Informix DB space, you indicate where the container is created, its initial size, and how it will expand as it fills up. The last step is to activate the time series. This can be done through a number of different operations, but the easiest is simply to insert a starter element. That element can contain valid data or can be empty. This is an example of activating a scuba diving time series with diving information for a particular dive site on the island of Bonaire in the Dutch West Indies. Once the time series is activated, any number of data load mechanisms can be used to load data into the time series, and data can be queried as well. To help application developers use Informix time series functionality, over 120 built-in functions are included in the technology. They can be called to execute directly on the data in its native format. These functions perform a wide range of commonly used operations such as averages, aggregates, scientific and math-oriented transformations, and more. In addition, data can be hidden or revealed to operations in order to easily ask what-if queries or to isolate strange, out-of-bound values from skewing results. In the first example, a 5-day and a 21-day moving average is being created, then intersected to see if or where the averages align. In the second, stock market transaction data for a particular equity is hidden in order to execute a series of what-if queries. Hiding the data means you don't have to write complicated inclusion or exclusion statements which can slow the query down. The last statement reveals the data to all operations. Finally, with the SQL view or virtual table, third-party tools such as IBM Cognos and others can use time series data for their operations. In summary, Informix time series is unique technology for time-oriented data. It uses a custom data type for efficient data storage and use, eliminating data redundancy and increasing performance. It includes over 120 routines for application developers to call and use directly against the data, simplifying application development and maintenance. And it includes an SQL view for third-party tool access. For more information on Informix and its technology, visit the URLs listed here. You can also learn more by viewing other in-depth videos on Informix technology, such as Introduction to Informix, its Internet of Things capabilities, or spatiotemporal processing. Informix. It just works.